Hello, good afternoon, and welcome to this lecture, this lesson. Today, we'll be looking at the Earth's external processes. Remember last time we were looking at the internal processes, those processes that have helped to shape the landforms on the surface of the Earth, or what we have also termed as the exogenetic processes. Because last time we looked at those internal, which we term as endogenic, we looked at faulting, we looked at warping, we looked at folding, and many others that have helped shape the landforms that do make up the morphology or the physiography of today's landscape. But in this recording, I want us to look at the Earth's external processes, those ones which operate after the internal processes have taken place, the landforms have been made, and then these ones also set in play and modify the already existing landforms. Because what we say, like when we're looking at the we're looking at the schools of thought, there are those who believed that, for example, historical geomorphology, those ones who say that what we see today is they are just remnants of what existed several years ago, implying that after those landforms were formed, certain processes set in play and modify them further to what we see them today. So landforms, and that's why even the mobilists say that the present is the key to the past, because what we see today was what existed long time ago. That what we see today are remnants. So processes after, for example, volcanicity has created landforms, the composite volcanoes, the basalt domes, and so on and so forth. Then there are other processes which set in play. These ones are basically controlled by the sun. The center at the center at the forces at the center of everything as far as subsurface and surface processes are concerned is the sun, is the one which provides the energy. So the very first process here is weathering, and we know very well, we have studied weathering before. We define weathering as the physical and chemical processes that change the characteristics of the rock on or near the Earth's surface. It is the process by which rocks on or near the surface of the Earth break down and change. Break down and change. Break down and change. So we said that it can also be defined as a process of alteration of rocks occurring under direct influence of the hydrosphere and the atmosphere. And that's why I said that the greatest influence here is the sun, because the sun is the source of all the energy that brings about, that facilitates these processes. So weathering eventually creates smaller and smaller pieces of rock called sediment. Examples, of course, we have mud, we have sand, we have silt, which are very fine particles. But how does weathering take place? We have already said that these are physical or chemical, implying that it occurs in two ways, or in processes of two nature: the physical processes and the chemical processes. The physical processes, of course, these are the ones which do not involve any change in the chemical properties of the rock. The rock, if the original rock which has undergone this process was limestone, after disintegration, it remains limestone. If the original rock that had underwent the process was gneiss, after the disintegration, it remains as gneiss. So there is nothing that changes in its chemical properties. And these physical processes, of course, they are quite several, like we shall look at them. But then we also have the chemical processes. These chemical processes, for them, involve a change, an alteration in the chemical properties of the rock. That if the rock, for example, is calcium carbon, they are calcium carbonate rocks, the outcome is not going to be calcium carbonate rock. The outcome is going to be different. If the original rock is limestone, the outcome is going to be a bicarbonate of some sort. It's not going to be the original rock. So there is a change in the chemical composition of the rocks that is under chemical weathering. And of course, then we have the biological, which simply action of plants and animals, but the disintegration is by physical or mechanical means. Mechanical weathering, we define it as the process by which rocks break down into smaller sizes without any change in the rock's composition. It's also referred as physical weathering, highly dependent on the rock type and time. The factors acting for significant period of time may cause mechanical weathering. So here there is nothing that changes. If it's basalt, it breaks down into smaller particles of basalt. And then of course, under mechanical weathering, we have these processes which take place. We have pressure release, which is a process under mechanical weathering. Of course, bedrock, which is a rock which has been buried underground for some time. When it's eventually exposed as a result of probably erosion and denudation, then that rock releases the pressure. In the process of releasing pressure, cracks, there is what we call, there is expansion and contraction. So cracks develop and the rock will peel off. That is what we call pressure release. But there is also what we call granular disintegration. And under granular disintegration, we look at rocks breaking. This is disintegration of rocks by physical means, where the disintegration follows well-defined joints within the rock into smaller granulars. And these granulars, of course, you'll find them as blocks of rock which almost have defined shapes. But these shapes, it's not human action, but it's because of the jointedness of the rock that facilitated their disintegration. The other physical weathering process is frost action, or what we call freeze and thaw effect. The breakdown of rock due to pressure exerted by freezing water. That when water collects within rock cracks, liquid water, the temperatures drop, the water solidifies. In the process of the water freezing, it occupies a larger space than liquid water. So the frozen water exerts pressure on this rock crack, and eventually the crack of the rock expands further. And the continued freezing and thawing eventually will bring to the complete disintegration of a rock. This kind of process is common in areas of very low temperatures and very low rainfall. That's why we talk about mountainous, high altitude areas, because that's where the temperatures and the rainfall are less. Then exfoliation is the other, which occurs as cracks develop parallel to the land surface as a consequence of reduction in pressure during uplift and erosion. Exfoliation commonly occurs due to alternate heating and cooling of the rock. That during daytime, we know, like for example here in the tropics, the humid tropics, there is intense heating of the rock. But then we know very well in the afternoon the convection rains come quite quickly, because there is too much moisture in the skies, so the convection rains come quite quickly. And when the rain comes, it quickly cools the rock which had been just heated. And that sudden cooling of the rock makes it to develop cracks and begins to peel off into layers. Some people will call it onion weathering. That is, eventually we call it exfoliation weathering. So that is under physical means. And then biological, I've already talked about biology, what takes place when the rocks are worn away by living organisms, trees and other plants, which grow within the cracks. And therefore they are under biological weathering. Here we're looking at plant root action. When the plants grow within these cracks, their roots tend to penetrate through those cracks further. They keep penetrating. As the crack opens up, the root enters further. As the crack opens up, the root enters further, and eventually you find that the whole rock disintegrates. When you go to major these areas of rock outcrops, like for example in Fort Particle there, you'll find trees growing on the rock, and the rocks have been disintegrated because of the plant root action. But there's also action of bacteria, plant bacterial organisms known as bacteria, algae and moss, which grow on rocks and produce chemicals which can break the surface layer of the rock. There are also burrowing animals like rabbits and squirrels, which dig up the ground, hence leading to formation of cracks within the surface within the rocks. So all these ones are under biological weathering, action of plants and animals. Then we have chemical weathering. Under chemical weathering, I've said that this one involves the change in the chemical composition of the rocks in the mineralogy. If the rock was magnesium-bearing rock, the outcome is going to be something else, probably magnesium something. You know, you guys, you studied chemistry. You know very well if you get oxygen plus water, oxygen plus hydrogen, you get water. If you get, for example, copper sulfate plus weak carbonic acid, what do you get? If you get calcium carbonate rock plus water, which rainwater, which is a weak carbonic acid, because rainwater dissolves with the carbon dioxide in the atmosphere to form carbonic acid, the outcome is going to be a calcium bicarbonate. Very different from the original rock. So the degree of chemical weathering depends on the type of the rock. For example, limestone is more readily chemically weathered than granite. So chemical weathering tends to thrive in softer rocks that have less degree of resistance, and also rocks which can easily dissolve, rocks which are easily permeable. Those permeable rocks which can allow water to go through them, but they can also easily dissolve in water. There we find that chemical weathering becomes quite swift and very fast. Factors that affect the rate of weathering, of course, very first one, we have climate, one of the most important, through its elements of weather, of temperature and rainfall. Those are the two important catalysts for any chemical reaction to take place. Where there is no water or where there is no heat, a chemical reaction will not take place. But where the two exist, the rate of chemical reaction is very fast. And that's why when we talk about the humid tropics, high rainfall, high temperatures, chemical weathering is predominant. When we talk about the arid areas, high rainfall, high temperatures, low rainfall, physical weathering and chemical weathering do occur. When we talk about high altitude areas, the temperate world, low rainfall, low temperatures, chemical reactions are limited. So physical weathering dominates. This is climate influencing the rate and the nature of chemical weathering. We have the nature of the parent rock. Nature of the parent rock is very important because, like we have just been mentioning, that it all depends on the nature of on the type of the rock. And nature of parent rock, here we're talking about the properties of the rock. I usually tell my people, my students, that imagine, I am going to assume some of you, I know you've never been in a relationship, but many of you have been in relationships and you are still in relationships. I know, my friend Joel, you must be, beg your pardon, I'm mentioning a wrong name, but you could be in a relationship. In relationships, people on this platform, my people at here and main campus, you guys in Mbali, in Kabale, Arua, when someone in school, when we were in school, we used to have these girls where you would think that people would even conclude that for that one has no feelings. Very beautiful, every boy goes there, but you don't return with a conducive answer. She keeps chasing everybody. She keeps chasing everyone. And because of that, you are repelled away. You study from senior up to senior 4, finish, you leave school. Nobody has ever succeeded. But then there are also these ones who are what people you call term as easy come, easy go, who are so merciful. When you go there and you pour out your desires, she'll say, Bambi, this person here, and she will help. So the same thing happens to rocks. Rocks which are resistant to erosion are not going to be easily broken down, whereas those ones which are soft are easily broken down. So we are talking about rock hardness. We talk about rock color, that dark colored rocks get heated so fast because they are absorbers of heat, and therefore eventually they disintegrate faster, whereas light colored rocks, they take long to get heated up because they reflect much of the heat, and therefore they take long to disintegrate. We talk about the mineralogy, the nature of the minerals within the rock will determine what kind of chemical reaction is going to take place. Because water, much as water reacts with almost all chemicals, but the rate at which it reacts with those minerals differs. The rate at water reacts with sugar is not the same rate it reacts with other minerals, because sugar is a soluble mineral. Salt is a soluble mineral. So if the minerals are not soluble, then solution weathering isn't going to be a success. We talk about the nature, the jointedness of the rock. You know, this disintegration utilizes the existing joints, those cracks. When we're talking about volcanism, we said during the process of crystallization, cooling, depending at the rate at which the magma cools, it allows for crystallization to take place. And that process of forming those crystals, those are the lines of weakness, where if the rock cools slowly, it develops those joints, which become the lines of weakness. But if it cools very fast, those joints are not there. And therefore, a well-jointed rock can easily disintegrate. Texture is the other property. Permeability. Do you allow water to go through or you don't allow? If you don't want, if you think you don't want, for example, my brother to approach you, you don't want to fall in love, don't offer an audience. I usually tell my students that if you are not ready for a relationship, don't offer an audience. Some of these guys use witchcraft. You may be born again, but you are a lukewarm Christian who is not, the Holy Spirit is not sufficient in you to warn you. So the moment you offer the person the audience, the devil comes. The devil comes and camps in your place because the person is using witchcraft. Don't give the audience to the person if you're not ready. The nature of the parent rock determines the rate. Rate, we are talking about the speed, and nature, we are talking about the type of weathering. We look at vegetation cover being another factor. We know vegetation under biological weathering also aids weathering. Where we have plant leaves falling on the rock and excluding that chemical from the leaves, which chemical eventually reacts with the minerals in the rock, and the rock begins to decay. You've ever seen a rotten house roof because above it there is a tree which keeps dropping leaf litter on the roof, and eventually the house begins to rot away because the chemical in the leaves is reacting with the chemical in the roof of the house, and then it begins to rot away. But the plant roots, we have talked about the plant roots, which do also aid biological weathering. We have topography, relief. The rate of weathering on the top of the mountain may not be the same as the one in the valley, because on a steep slope, whichever material disintegrates is moved away to the lower slope, and eventually leaving the slope exposed. Remember, we said the source of energy for the weathering process is the sun. So once everything that disintegrates is washed away, then the slope remains exposed to the agents of erosion. And the rate on such a slope is going to be faster, higher than in the valley where there is deposition, where the material, where the rock is being protected from the agents of erosion, of the agents of weathering. We have living organisms. Living organisms, quite important. They also play their part. I've already explained. We have the squirrels, we have the termites, we have the moles, those rodents. We have the grazing animals. We have man. Man's activities, quarrying. You go there with your chemicals, you can blast a rock. Within just a minute, you've disintegrated the whole rock. It's activities of man. You have road construction, where you go digging up the soil. Where you go compacting the soil. These are activities of man, and all of them determine the rate and the nature of weathering. I hope we are together. I hope we are together. Part of your homework here is for you to understand. I implore you to look out for certain landforms that result from weathering. I want those landforms. Of course, I will give you one of them. For example, is an Inselberg. An Inselberg results from weathering. What are the others? During the interactive session, I want you to give me all these landforms that result from weathering processes. All of them. That is homework for you. It's not assignment, but homework. You must give me the answers. God bless you and be blessed. I love you.